Good morning all. So in today's class we will look at the next theorem. So it is called Green's theorem in plane. So Green's theorem is a theorem which connects a line integral and a normal double integral. And Green's theorem states that if you have functions m and n which is having continuous, so they are continuous functions, and if they have continuous partial derivatives dou m by dou y and dou n by dou x in a region R of the xy plane which is bounded by the closed curve C, then the Green's theorem states that then integral over C m dx plus n dy is equal to double integral over R dou n by dou x minus dou m by dou y into dx dy, or this can be dy dx also. The order depends on how we are solving. So the integrand will be dou n by dou x minus dou m by dou y. So that is the Green's theorem. So by Green's theorem, provided m and n satisfies the given condition and R is a region bounded by a closed curve, then integral over C m dx plus n dy will be equal to double integral over R dou n by dou x minus dou m by dou y d. You can take it as dA, so it can be of any order, and here C will be taken in the anti-clockwise direction or counterclockwise direction. So that is the Green's theorem. And now we will see how to verify the Green's theorem. So we will see an example of verifying the Green's theorem. So you need to verify Green's theorem in the plane for integral over C 3x square minus 8y square dx plus 4y minus 6xy dy, where C is a boundary of the region defined by y equal to root x and y equal to x square. So this problem has two parts. So the first one is to verify Green's theorem over curve C which is a boundary of this region, either that is the different problem, y equal to 0, x equal to 0, x plus y equal to 1. Same integral you have to evaluate over a different C. So we will see the first part. So you have the curve C as y equal to root x and y equal to x square. So y equal to root x will be this curve, and you have y equal to x square. So the region bounded by the both curves is this portion. So this is y equal to root x and this will be y equal to x square. So we need to take in the, so this is the point 0 0 and point of intersection is this point is 1 1. Now you need to take in the counterclockwise direction, so that will be this direction. Okay, so now first we will evaluate. Okay, so here m will be equal to, so you have 3x square minus 8y square, and n is I think 4x minus 6xy. Yes, sorry, 4y minus 6xy. So that is 4y minus 6xy. So first you will evaluate double integral over R dou n by dou x minus dou m by dou y dA. So that will be double integral over R dou n by dou x will be minus 6y minus dou m by dou y will be minus 16y. So we will have dA, so that will be double integral 10y dA. Now in the region R which is bounded by these two curves, so we have y varying from, so y will vary from x square to root x and x is varying from 0 to 1. So we will take the order dy dx, so that is 0 to 1 x square to root x 10y dy dx. So that will be integral 0 to 1 10 y square by 2 from x square to root x dx. So that will be equal to integral 0 to 1. So we will get 5 y square from x square to root x dx. So that is integral 0 to 1 5 x minus x raised to 4 dx. So that will be 5 x square by 2 minus x power 5 by 5 from 0 to 1. So that is 5 into 1 by 2 minus 1 by 5. So that is 5 into 3 by 10. So the value will be equal to 3 by 2. So therefore the double integral will be equal to 3 by 2. And now we will evaluate integral over c m dx plus n dy. Now if you look at c is a union of c1 and c2. So c1 is y equal to x square. So here so you have c equal to c1 union c2. So c1 is y equal to x square and c2 is y equal to root x. So along c1 we will have dy equal to 2x dx. അപ്പോൾ നമ്മൾ ചെയ്യാൻ പോകുന്നതാണ് integral over c m dx plus n dy will be equal to integral over c1 plus integral over c2 m dx plus n dy. Now we will replace y by x. അപ്പോൾ y equal to x square ആണ് c1 c2 നമുക്ക് y ക്ക് പകരം root x യൂസ് ചെയ്യാം. So correspondingly replace dy also. So here dy will be 1 by 2 root x dx. So integral over c1 m dx plus n dy will be equal to integral. So you will be getting 3 x square minus 8 y square ആണ്. അപ്പോൾ 8 y raised to 4 8 x raised to 4 വരും. So 8 x raised to 4 dx വരും plus 4 y ക്ക് പകരം 4x square minus 6x minus 6x cube വരും and dy ക്ക് പകരം 2x dx വരും and x will vary from 0 to 1. So that is integral 0 to 1 3x square minus 8x raised to 4 plus 4 8x cube വരും minus 12x raised to 4 dx. So that is integral 0 to 1. So you will get 3x square plus 8x cube minus 20x raised to 4 dx. So upon integrating you will get x cube then plus 2x raised to 4 minus 4x raised to 5 from 0 to 1. So upon using the limits you will get 1 plus 2 minus 4. So that is equal to minus 1. Now we will take the next curve. So along C2 either you can use y equal to root x substitution use ചെയ്യാം. ഇനി in order to avoid the root you can take y square equal to x. I think this is easier. ഞാൻ ആദ്യം ഈ വേ വെച്ചിട്ടാണ് പറഞ്ഞത്. I think this is easier. So let us do using this one. So dx will be equal to 2y dy. അതായിരിക്കും നിങ്ങൾ പവേഴ്സ് ഇപ്പം 1 by 2 power avoid here, that will be easier. So dx will be equal to 2y dy, and again y will vary from 0 to 1. So integral over c to m dx plus n dy, that will be equal to integral over c to, so 3 x square ആണ്. അപ്പോൾ അതിനേരം 3 x square നേരം y raised to 4 വരും, minus 8y square അത് ടേം അതുപോലെ തന്നെ. then dx will become 2y dy, then next term 4y അങ്ങനെ തന്നെ minus 6y, x will be equal to y square. അപ്പം 4y minus 6y cube dy വരും. so okay, you can replace the limit from 0 to 1. So that will be integral 0 to 1. So you will get 6y raised to 5 minus 16y cube plus 4y minus 6y cube dy വരും. So that will be equal to integral 0 to 1 4y minus 4y minus 22y cube plus 6y raised to 5 വരും. 4y minus 22y cube plus 6y raised to 5 dy. So upon integrating you will get 2y square minus 22y raised to 4 by 4 plus y raised to 6 from 0 to 1. So that is 2 minus 11 by 2 plus 1. So that will be 3 minus 11 by 2. So that will be equal to minus 5 by 2. So therefore integral over c m dx plus n dy is equal to അപ്പോൾ നമുക്ക് ആദ്യം കിട്ടിയത് so you will get minus 1 sorry, there is one correction over here. okay, ഇവിടെ plus 5 by 2 വരും. നമ്മൾ here when you take the curve y equal to root x അല്ലെങ്കിൽ y square equal to x എടുക്കുമ്പോൾ we have taken y varies from 0 to 1. So it is actually 1 to 0. അതുകൊണ്ട് നമുക്ക് ലാസ്റ്റ് ഒരു കറക്ഷൻ വരും, ഒരു മൈനസ് സൈൻ എക്സ്ട്രാ വരും. സോ ദിസ് ഇസ് ഓക്കെ. സോ ഇൻസ്റ്റെഡ് ഓഫ് ദിസ് യു ഹാവ് y varies from 1 to 0. So I am replacing it from 0 to 1. അപ്പോൾ ഒരു നെഗറ്റീവ് സൈൻ പുറത്ത് വരും. സോ we will have a negative sign outside. So മൊത്തം ഒരു minus 1 വരും. So that is minus of 5 by minus of minus 5 by 2 plus 5 by 2 വരും. So therefore the first integral അപ്പോൾ c1ൻ്റെ integral minus 1 ആണ് plus 5 by 2. So minus 1 plus 5 by 2 will be equal to 3 by 2. So that was the required integral in the first part. So therefore theorem is verified. So that is the Green's theorem when you have the first curve. Now part B was, so you have a region which is bounded by x equal to 0, y equal to 0 and x plus y equal to 1. So it is a line x plus y equal to 1. So this will be the point 1 0 and this is the point 0 1. So this is 0 0 and here you have y equal to 0 and this is x equal to 0. So you need in the counterclockwise direction. So let me take it as O, A and B. Now first we will evaluate double integral over r dou n by dou x minus dou m by dou y dA. So n is equal to 3x square minus 8 y square, sorry, this is m, and n is 4y minus 6 xy. So double integral over r nx minus my dA is equal to double integral minus 6y minus plus 16y dA varum. So that is double integral 10y dA. So we will have double integral 10y. So you can take any order of integration. So let me take dx dy. So x will vary from 0 to 1 minus y, and y will vary from 0 to 1. So that is integral 0 to 1 10y 1 minus y dy varum. So again when you integrate, that will be integral 0 to 1 10y minus 10y square dy. So that is 10y square by 2 minus 10y cube by 3 from 0 to 1. So that is 10 into 1 by 6. So you will get 5 by 3. So the first integral will be equal to 5 by 3. And now we will find out integral over c m dx plus n dy. Now c will be OA union AB union BO. So along OA you have y equal to 0. So dy will be equal to 0. So integral m dx plus n dy along OA will be integral. So along OA that y equal to 0. So you will get 3x square dx, രണ്ടാമത്തെ term 0 ആവും. So x will vary from 0 to 1. So that is x cube from 0 to 1. So you will get 1. And along AB, so AB you have x plus y equal to 1. So let me take y equal to 1 minus x. So dy will be equal to minus dx, and x will vary from 1 to 0. x ന്റെ AB എടുക്കുമ്പം 1 to 0 ആയിരിക്കും വേരി ചെയ്യുന്നത്. സോ integral over AB m dx plus n dy will be equal to integral 3x square minus 8 y square വരുമ്പോൾ 1 minus x whole square dx plus 4 into 1 minus x minus 6x into 1 minus x minus dx, and x will vary from 1 to 0. So that is integral 1 to 0 3x square minus 8 1 minus x whole square. നമുക്ക് plus 4 into x minus 1 എന്ന് എഴുതാം, plus 6 x minus x square dx.